Laplace transforms. What is it? Why do we need it? Well, there are many engineering problems expressed as a linear differential equation. Okay, for example, this kind of linear equation: mechanical design, electronic circuit analysis. Those linear equations, there's no universal way to solve it, but now it has we have a good way to solve those. To give you example, DC current circuit is Ohms law, very straightforward. The AC circuit, what we do is we convert each element into a complex number and use as impedance. And complex number is going to solve this easily using algebra, because all the characteristic of this inductance and the capacitance are translated into the phase of the signal. Now, transient circuit analysis. When it comes to the transient analysis, there's no way. For example, you give an impulse or step function, and what's happened? Step function is like a switch. You suddenly turn on the switch, apply the voltage, and then what's happened to the current inside? It's going to be linear differential equation, and we have to solve this to know what's going to happen. Okay, so differential equation and linear, okay, the nonlinear one is tough. There's no universal way to solve it, but a lot of problem is approximated to linear differential equation in the mechanical engineering and electronics engineering. So what we do is to transform the differential equation using Laplace function. Laplace transforms create transformed equation, and you organize it using algebra and inverse transform. Then you will get these effects. So you start with unknown y equal ft. I use the t because it's mostly start with t 0 to infinity. Okay, now what happened to the system when time 0, some kind of force applied or voltage applied? Okay, so that's a function ft. We want to know, but the equation is going to be differential equation. So convert that by Laplace transforms and using algebra to organize it. Then inverse transform it to get ft. So it's a great help to solve the linear function. So what is transform? Laplace transform of function ft is given by integral form, ft times e to the negative st dt, and this linearity of transform is very simple because you have a here, and b, it come out, a and b come out, so we have a linearity, right? That means when we organize transform function into two terms with linear fashion a and b, then we can inverse transform this one, each one, to get the original function. Example here is like a step function. When the function is 1, that means the voltage go up to 1 volt, or could be any volt V, then the transform function is 1 over s. S is positive. For example, you give step function that's the same as switching on here, right? And volt. Okay, so what's happened is going to be only 1 over s. Another example of transform function, Laplace function, is only t to the nth is like a quadratic voltage. When you apply quadratic voltage, what's happened? Its Laplace function is like this. Okay, and now we go over all the basic function, transform function. Then later in the next 2 videos show you how to inverse transform and obtain the function you want to know, like I t. Okay, this is called transient analysis. Okay, so please move on to the next video, Laplace transforms number 2. If you like this video, please subscribe.